Hello everyone, welcome to our video series diving into uDraper Cinematic, our latest tool designed to tackle self-collisions and handle multiple layers for complex clothing designs. Keep in mind, this is just the beginning phase of rolling out this enhanced new solution, and it comes with a separate license. If you're itching to give it a try, don't hesitate to reach out to us. First, let's quickly run through the process. Then we'll delve into the specific workflow you might use in your work. Start by adding the Draper components to your character skeletal mesh, ensuring you have a valid uDraper cinematic license. In Marvelous Designer, ensure your avatar matches the one in Unreal Editor and the clothing fits the avatar properly. Hide other garments if you're importing a specific one. For texture baking, prepare the UV map accordingly. Adjust the particle distance for the garment mesh. In Unreal Editor, select the Draper garment component. Use the Import MD button, choose a folder to save the imported garment data. Select Cinematic Engine and Texture Processing options. Then click Import. The import process will run automatically, positioning the garment perfectly on the avatar. Next, fine-tune the material properties in the Draper editor and, optionally, select a material preset in JSON format from Documents 3D Draper Materials folder. If needed, adjust settings for cinematic simulation. Open your level sequence and opt for either movie rendering or uDraper cache. The latter creates an Unreal Geometry cache asset with all clothing materials. Finally, record your animation. That sums up the basics of using uDraper Cinematic. If you're already familiar with the basics of uDraper, feel free to skip ahead to the next segments in this video. Now let's delve into the specifics. Today, we're kicking things off by exploring an apocalyptic outfit we found on ArtStation, created in Marvelous Designer. As we delve into it, we'll notice numerous pieces sewn intricately atop one another, layers upon layers. Picture this layer overlapping that one, and this piece sewn onto the main coat. Same with the pants. They're equally intricate, complete with straps around the sleeves and legs, and more. It's clear that attempting to simulate such an outfit using the old uDraper would have required simplifying the design significantly to avoid messy entanglements between layers. Okay, here's the deal. Most of the clothes you find online for Marvelous Designer are fitted to either Marvelous or DAZ mannequins, striking specific poses. So, if your Unreal character doesn't match up with the one used in your Marvelous Designer project, you'll need to refit those clothes. To keep things simple, we're rolling with a metahuman character here. Let's get it ready for refitting in Marvelous Designer, aiming for the same fitting pose. We'll start from scratch, cleaning everything up and resetting our metahuman to its default pose, bent arms and all. We want to make sure that our character matches the pose in our Marvelous Designer project, featuring a DAZ male character. So, we import that DAZ avatar. Adjust our metahuman's pose accordingly. And voila, we're almost there. Now that our character's striking the right pose, we add the usual Draper components to the metahuman's body component. And from the Draper simulation component, we'll export our collider mesh in OBJ format. Now we can import our collider mesh into Marvelous Designer. Let's speed up the refitting process by setting the particle distance to 20 millimeters. Starting the simulation. Looking good so far. Now, let's assign different materials to specific parts of the garments, so it would be easier to adjust their properties in Unreal Editor. For instance, the pants with different fabrics for different sections, distinct materials for straps, waistband, and so on. Let's talk about the cape. While it rocks a main material, its loose nature during animations could be problematic. To tackle this, we've introduced an extra material for the top part of the hood and designated cape arm to keep it snug around the arms. Moving on to the sweater, we have a few materials as well. Think sweater, sweater 2, and even a separate one for the neck, so in Unreal, we'll have more control over each part. Last but not least, those arm straps have got their own unique material too. That's the breakdown of how we've handled materials across this ensemble. Now, if we're aiming for those top stitches to pop in Unreal, it's crucial to set their type as texture. So instead of sticking with OBJ, we'll set them up as texture and maybe tweaking sizes and colors along the way. When it comes to importing garments from Marvelous Designer into Unreal Editor through uDraper, we're presented with a couple of options: copying existing textures or baking them. If our goal is to bring those intricate details like top stitches, prints, or overlays into UE, baking is the way to go. In this tutorial, our focus is on importing baked textures to ensure those top stitches won't be lost. However, if your project doesn't need this level of detail, feel free to skip this part. Since we're baking textures, each garment's piece must fit into that garment-designated UV quadrant. Otherwise, if we export just one garment with baked textures while other patterns are scattered across the UV map, Marvelous Designer will bake textures for all used quadrants. This causes lengthy waiting times and potential timeouts during import. Let's talk simulation performance. Obviously, the less triangles you've got in your garment mesh, the faster the cloth simulation runs. With that in mind, we'd suggest starting with a lower poly mesh by increasing the particle distance. Once we're happy with how the simulation rolls out, we'll switch gears to a finer mesh with more triangles and a lower particle distance for that final cut. So let's set the particle distance to a modest 18 millimeters for our initial test simulation. It won't keep us waiting too long. Then we run the simulations to ensure perfect draping and, most importantly, zero entanglements between them. Everything looks shipshape, and we're ready to import our garments into Unreal Editor. Unlike our previous real-time version of uDraper, our new cinematic version of uDraper allows us to import an entire outfit, even if it's made up of separate pieces, in one go. However, we still recommend importing each garment separately because it can boost performance and offers flexibility for tweaking individual pieces. Let's start by importing these pants. To do that, we'll hide the shirt and cape for now. Since it's a quick test, we're skipping the texture baking and won't worry about the UV maps for that matter. Switching gears to Unreal Editor, we'll select the garment component, hit the MD button, choose a folder to save the imported garment data, select Cinematic Engine and Texture Processing options. Also, keep in mind that real-time and cinematic simulations aren't compatible, so you can only simulate garments imported for one engine at a time. No texture baking for this quick test. Hit Import and let the script do its thing. We'll fast forward this process. Once the import is finished, we see the pants perfectly fitted to our avatar. Save that garment and we're good to go. Since this is just a quick test, we won't dive deep into setting up all the material properties in the Draper editor at this moment. We'll save that for later in the video when we'll get ready for the final cut. Quick tip: you can access the Draper editor by clicking on the pencil icon within the Draper garment component. For now, our focus is on assigning some bindings specifically for the waistband and straps. We've covered detailed tutorials on binding in the past. Check the link in the description if you need a refresher. The only tweak here is the updated range for binding strength. Don't forget the golden rule: always save your material settings after applying new changes. Here's a nifty trick. We've got a bunch of presets for material properties. Clicking on Open Fabric Preset allows us to choose from preset files in JSON format. By the way, these presets are stashed in your documents 3D Draper materials folder for easy access in the future. Let's opt for a denim preset, applying the physical data in the physical parameters section. Also, now we can copy these physical settings and paste them onto another material just like this. Hit save to keep your new material setting. Before we delve into animation, let's clarify that uDraper Cinematic is not a real-time solution. Clicking play or simulate won't trigger the cinematic simulation. It's designed to work with Sequencer for rendering videos or recording geometry cache. Now let's kick off our first simulation by opening this animation sequence. We highly recommend starting the sequence from the same pose we used for exporting the garment. To record Unreal Geometry Cache, we'll select the uDraper Cache option. This allows for a detailed examination of the simulation result from various angles. Check out our tutorial on recording geometry cache for more detailed steps. Link in the description. Simply pick a folder for storing the geocache and materials. Once the preview window pops up, the simulation begins. This quick run is just to ensure everything's working smoothly. We can interrupt the simulation at any point. The resulting geometry cache is saved in its designated folder for inspection. We'll temporarily disable the pants, place the geometry cache in our scene and sequence, giving it a spin from different angles, ensuring everything's on point. If everything looks good, we can remove this cache, re-enable the pants, and continue with our process. Let's bring in the shirt. First, hide the pants and show the shirt in our scene. Now, back to the import process. Select the shirt draper garment component, hit MD, choose the import folder, ensure cinematic is selected, and click import. Fast forwarding through the import. Voila, the shirt's in. For now, we're skipping material details, just binding the straps to avoid any mishaps during animation. Adjusting the thickness slightly to fix any clipping. For the Draper simulation settings, quality set at 2, other settings untouched. More on these in our next tutorial. Time to record the simulation cache again. Speeding through the process so you won't fall asleep. Looks good, so let's halt the recording and bring in the cape to test all 3 garments together. Now, we hide the shirt, reveal the cape, repeat the import process in Unreal Editor. Again, quick test, minimal fuss about materials, just binding the hood and arms to ensure everything functions smoothly. Another swift cache recording, then a peek at the cache. Hiding garment components, dropping the new cache into the scene and sequencer. Keep an eye out for any fabric clipping. If present, it's likely due to the quick fabric thickness setup we did to save time. Otherwise, all seems to be in order. If our preliminary test runs check out, let's gear up for higher quality simulation and rendering. To achieve this, we'll adjust the particle distance, aiming for a more refined mesh while ensuring it remains manageable. Decreasing it to 12 mm allows for increased detail without overwhelming complexity. It's important to note that having the particle distance will quadruple the number of triangles. Before exporting, we need to run a precise fitting to ensure everything's in place and no entanglements occur. Let's run a fitting to confirm. Now, let's repeat the import for new meshes, this time opting to bake textures to ensure the visibility of intricate details like top stitches in Unreal Editor. As we import each garment separately, it's essential to ensure their UV maps are positioned within the first quadrant during the export. Again, starting with the pants, we'll isolate them by hiding the shirt and cape. Upon import, we'll select the cinematic simulation option with texture baking, specifying the image size, e.g. 4096, for higher resolution textures. As we proceed with the import of all 3 garments, this time focusing on texture baking, it's crucial to position the UV map correctly for each exported garment within the first UV map quadrant. For example, during the export of the shirt, it's essential to relocate any parts related to the pants away from the first quadrant and place the shirt's pieces there to ensure proper baking of textures. Repeat the process for the cape. With everything imported successfully, the next step is to prepare our materials for recording the simulation cache. Beginning with the pants, we'll follow the same procedure as we did earlier with uDraper. This involves fine-tuning the thickness for various parts of the pants, for instance, setting the waistband thickness to 3 mm and establishing an edge curvature of 1 for improved realism. Additionally, we'll reapply the binding to the waist as we did previously. After configuring these settings, we'll save this material and proceed to adjust materials for other parts of the pants and not overlook the binding of the straps. To ensure accurate simulation, we need to select a preset with specified physical properties. These presets' JSON files are located in your document's 3D Draper Materials folder. Moving on to the shirt, let's give it a slightly fuzzier appearance while keeping a thickness of 1 mm and default physical settings. For the neck piece, we'll set the thickness to 3 mm. Adjusting the straps, we'll set their thickness to 2.5 mm and add a curved edge for a more natural look. To prevent unwinding during the simulation, we'll bind the straps securely. Finally, we bring up the cape and adjust the fabric settings. We're going to keep default physical properties for now. Before diving into the simulation, let's take a quick look at the new Draper simulation settings available specifically for cinematic simulation. Within the Draper simulation component, you'll notice two options: the familiar real-time setting and the new cinematic simulation settings. Now, we're planning a detailed tutorial on these settings, but for this test, let's stick to the basics. Here's the rundown. We'll set the quality to 2, maintaining the solver iterations at the default 10. Substeps are currently set to -1, allowing the program to estimate the necessary substeps based on the quality setting and the number of outfit meshes polygons. Increasing the quality will naturally boost the number of substeps, but alternatively, you can specify a precise number here if needed. Moving on to the collider section, the inner thickness specifies how deeply a cloth can safely penetrate the avatar's mesh. It must not exceed half the avatar's cross-section in the areas where the cloth contacts the avatar. The outer thickness determines the gap between the body and the cloth. It's somewhat similar to Marvelous Designer's skin offset settings. For now, we'll maintain the other parameters at their default values. Moving on to the cloth section, let's set both the cloth and self-thickness to 2 mm, keeping them in line with Marvelous Designer's settings for now. Here, you'll also find a few intersection filters designed to handle potential entanglements, such as cloth self-collisions and interactions between the avatar and the cloth. While these can be very helpful, we'll explore them more thoroughly in an upcoming tutorial to better understand their impact and functionality. Now, let's proceed to the much-anticipated moment, recording our final geometry cache. It's important to note that with the smaller particle distance and higher resolution mesh, this simulation will understandably take more time. To save time in our video, we'll fast-forward this process. Once the geometry cache is ready, we can use it for our final video rendering. Thanks for watching.